So we're continuing with this chapter 15, question 12. Now we're going to B, where it's asking, is this statistically significant? We're going to use a two-tailed test with an alpha of 0.05. And then in part A, we already calculated the correlation. So we've already done step 3 of the hypothesis testing procedure. What we're now going to do is go back and do steps 1, 2, and 4. Step 1 of the hypothesis testing procedure, step 1 is always state your hypotheses. In this case, we've got a two-tailed test. So our null and our alternative. Here, the test statistic, the population parameter that we're trying to make a decision about, that's rho. This sort of weird looking P thing. So the null is that there is no correlation, that that it's 0, right? That rho, the correlation in the population is 0. And the alternative is that it's not 0 because this is a two-tailed test. Step 2 of the hypothesis testing procedure, we need to have that it's a two-tailed test. We need our alpha level and we need our degrees of freedom. Degrees of freedom for correlation is n-2. We had 10 pairs of scores, 10 people responding, -2. So our degrees of freedom is 8. We're going to take that and go to the statistical tables. And if we want, we could either do further calculations after we calculated our R and convert it into a T and use our t-test tables, or we can stop at an R. We have a critical values table for that. When we're looking here, we look at level of significance for a two-tailed test, because that's what our question asked for, an alpha of 0.05. And we go down, and this table even has the degrees of freedom formula here for you. We have 8 degrees of freedom. And so we go over, and our critical value, technically values, critical values, because it's a plus or minus, because it's two-tailed, is 0.632. Now, typically, if we were doing the full 4-step hypothesis testing procedure in order, we would now calculate the R, the test statistic. But we already did that in part A, and this is the value we got, right? We got minus, sorry, you can't necessarily see that, but there's a minus here, and that minus 0.91. So in step 4, what we need to do is compare this value to the critical values and see whether or not we're in the critical region, this region where we say, yeah, no, there is a statistically significant effect or not. So we have a two-tailed test. So we have a tail over here and a tail over here, where if the value we calculate falls in either of those regions, we're going to say that there is, we're going to reject the null and accept the alternative and say there is a statistically significant relationship between our variables. Those cutoff values, minus 0.632. Let's see if I can block my glare here. So minus 0.632 and positive 0.632. The value we calculated was minus 0.91. So we're in this critical region. We're going to reject the null. We're going to accept the alternative. This is evidence showing that you're not just guessing. And to interpret this, there is a statistically significant relationship. And we can pull this a bit further between weight and income for women. Okay, just pulling it back to what the variables actually were. So that is our full question. I'm going to do another little bonus piece in a moment, looking at effect sizes, even though it isn't actually asked in the question.